This week on the show, we have FreeBSD ZFS on Linux performance comparisons for you. Dragonfly 5.4.2 has been released. We contain web services with iocell in a tutorial. Solaris 11.4 is available. Problem with SSH Agent Forwarding we were discussing. OpenBSD 6.4 to 6.5 upgrade guide we have, and more in this week's episode of BSD Now. BSD Now, episode 297, Dragonfly in the Wild, recorded for the 8th of May, 2019. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And we're here with this regular episode every week, as always, with headlines as exciting as they could be. FreeBSD ZFS versus ZFS on Linux performance benchmarking done by Phoronix.
Mm-hmm. So this compares the older native ZFS to the new port of ZFS on Linux to FreeBSD, and then uses the ZFS on Linux on Ubuntu as a reference.
Okay, good. Baseline.
So they're using an Intel Xeon E3 1275 V6 with an Asus P10 SMWS motherboard. So that's the exact CPU I have in the machine I'm sitting at right now, although I have a Supermicro motherboard. Anyway, it's got 2 sticks of 8 gigs of RAM, a Samsung 970 EVO Plus 500 gig NVMe solid-state drive. So you're using just a single modern NVMe SSD so that we could run the tests. And so they compare FreeBSD with ZFS on Linux, FreeBSD with its native version, UFS, and then Ubuntu 18.04's version of ZFS on Linux.
Oh, that's a bit older. Yeah.
Mm-hmm. Well, it's the stable release.
Yeah, but that should give people a good amount of.
So right away, looking at the SQLite test, this one actually apparently had some problem with UFS, but comparing Ubuntu ext4 versus ZFS on Linux, the number of seconds it took to do a series of SQLite inserts, ext4 took about 40 seconds, whereas FreeBSD's native ZFS and Ubuntu's ZFS on Linux both took about 27 seconds, but the new ZFS on FreeBSD took only 22 seconds.
Oh.
The blog benchmark, I think something is slightly fishy here, or maybe not. Nope. Looking at that, FreeBSD beat out both types of Linux, and actually the winner was again the FreeBSD with ZFS on Linux.
Oh, okay, interesting.
But giving quite the walloping to Ubuntu in that one.
Oh yeah.
And then so that was BlogBench read test. So of course ZFS does well. On the write test, however, the results are the other way around, with Ubuntu's results being much higher. Although ZFS outperformed UFS because of the bigger cache.
Yeah, compression and all these things.
Mm-hmm. And then they did iozone, and again, in this case, UFS provided faster write performance. Of course, UFS has to do less work. Overwrites are in place, and the metadata is much smaller and doesn't have to be written as much. Whereas, but you can see that ZFS on Linux port to FreeBSD is faster than native ZFS on Linux in this case.
I see, yep.
And then in the dbench, which I think is a database benchmark, with just a single thread, UFS was way out in front. But when you add multiple threads, well, about the same actually. But FreeBSD winning there as well. Then disk transaction performance, the ZFS on FreeBSD slightly ahead of the older native ZFS.
Oh, yeah, cool.
So I'm going to say overall, the FreeBSD ZFS on Linux port is looking good so far, and I'm looking forward to this maturing and eventually being part of FreeBSD 13.
Yeah, that's a good start in the numbers. So we look forward to more once they have been fully integrated. Okay, then we have Dragonfly BSD 5.4.2 is out or in the wild. And here you can see from the announcement page that Dragonfly BSD version 5.4 brings new system compiler in GCC 8, improved NUMA support, a large number of network and virtual machine driver updates, and updates to video support. And of course, this release is also 64-bit only, as many of those before. But Dragonfly 5.4.2 has a fix for a rare potential Hammer 2 corruption problem. And other minor 5.4 changes are marked here now in the full notes. So the big ticket items are much better support for asymmetric NUMA, which is the non-uniform memory access configuration. And in particular, both the memory subsystem and the scheduler now understand the Threadripper 2990 W-axis architecture. Cool. The scheduler will prioritize CPU nodes with direct attached memory, and the memory subsystem will normalize memory queues for CPU nodes without direct attached memory, which improves cache locality on those CPUs. And there was incremental performance work that Dragonfly did. As a whole, there's a very SMP-friendly release now available, Dragonfly. The type of performance work they're doing now mostly revolves around improving fairness for shared versus exclusive lock clashes, reducing the cache ping-ponging due to a non-contending SMP lock, or other things. Major updates to D-ports brings to us with a week or two of FreeBSD ports as of this writing or the release notes here. In particular, major updates to Chromium and making the whole mess work with GCC 8. Major rewriting of the TTY C-list code and the TTY locking code, significantly improving the concurrency across multiple TTYs and PTYs.
Nice.
And they also have a section on GCC 8. Dragonfly now ships with GCC 8.0 and runs as the default compiler. It's also now used for building D-ports, whereas GCC 4.74 and GCC 5.4.1 are still installed. 4.74 is their backup compiler, and 5.4.1 is still there to ensure a smooth transition, but both should generally not be used. Build Vault installs all three by default to ensure maximum compatibility. Also have three compilers. Okay. Many passes through world sources were made to address various warnings and errors the new GCC brought with it. And here are the Hammer 2 things. So Hammer 2 is recommended as the default root file system in non-clustered mode. The clustered support is not yet available. They have increased bulk-free cache to reduce the number of iterations required. They fixed numerous bugs. There's also a link to the one rare potential one above. And they have improved support for low memory machines. Oh, that's good. So that makes Hammer available to a little bit more machines in this low memory space. Significant pre-work on the XOP API to help support the future networked operations. And in 5.4.1, the previous release to this one, the Hammer 2 file system meta consistency protection for snapshots and crashes has been improved as the speed of snapshots generation. And there's full notes at the end of the document. You can find all things, details, update instructions, and checksums in this document. And yeah, check it out. If you have Dragonfly 5.4.1 or a previous version somewhere installed and tried it out and have a blog post for us, then send it to us. It would be interesting to cover it in a future episode. So, time for the news roundup. In this week, we have containing web services with iocell.
Yeah, so it starts off with the author here saying, I'm a huge fan of the FreeBSD jail feature. It is a great system for splitting services into logical units with all the performance of the bare metal system. In fact, this very site runs in its own jail. If this is starting to sound like LXC or Docker, it might surprise you to learn that this OLS level virtualization has existed for quite some time. Kudos to the Linux folks for finally getting around to having it. And it says, if you're interested in the stories behind jails, they actually have a link to the Papers We Love talk about the spawning of jails and what came after, and so on. So getting started. There are plenty of options when it comes to setting up jails on a system. Most popular are EasyJail and iocage, like we talked about last week. Or you could do everything manually. iocage was recently rewritten in Python, but was originally a set of shell scripts. That version has since been forked under the name iocell. The shell version is iocell. And I think it's pretty neat. And so this tutorial was actually using iocell. So to start, they have a FreeBSD install. I guess this tutorial might be a little, it's from 2017, so it's using FreeBSD 11.0. You should do this with a newer version. But they have the iocell package and a ZFS pool. So they activate iocell on the pool, and then you can see that sets up the database or the file system structure. Then you can create a new jail, in this case, my web server, and then start it. And now when you do iocell list, you'll see the running jail. And if you do iocell set boot equals on for that my web server and use sysrc to do iocell underscore enable equals yes, iocell will start at boot.
Yeah, so your jail will be right
it walks
there.
through how to set up networking, whether you want to use IP addresses that are already on the system, or if you want it to bind aliases for you automatically, using the iocell console command to get inside of a jail and poke around, enabling raw sockets in a jail. Raw sockets in a jail are disabled by default so that something inside a jail cannot spoof its IP address. But if you want to run, say, a monitoring system from inside the jail and want to be able to send pings, you're going to have to enable that.
Yeah, otherwise there's nothing returned.
Yeah. Well, no, you get an error when you try to send a ping.
Yeah, from within the jail. Yeah.
You can also use iocell pkg to install packages inside the jail, rather than having to console in and manually run the commands. It shows how they set up their nginx.conf inside the jail and their PHP FPM to run the web service and all that.
Oh, cool. So that should get people started on that.
That's all you need to get a website going in a FreeBSD jail.
Okay, then we have a story about Oracle Solaris 11.4 SRU8. They write that in their release notes or the announcement that today we're releasing the SRU8 for Oracle Solaris 11.4. It is available via package update from the support repository or by downloading the SRU from the My Oracle support doc. And this SRU introduces the following enhancements. Integration of an issue where a firmware update or the query commands will log EE reports and repeated execution of such commands led to faulty degraded NICs. The issue has been addressed in this SRU. They also have UCB, like libucb, librpsoc, libdbm, libtermcap, and libcurses libraries reinstated for Oracle Solaris 11.4. They also reintroduced the service FC Fabric and the iBus. Yep, for having that. I guess it was removed somehow. And iBus
software updates. So they have newer versions of NTP, the ESR of Firefox, Bind, OpenSSL, MySQL, Wireshark, and the Apache web server.
Yeah, so grab that latest release if you're in Oracle space.
They've also updated the package.depot package.
For the latest, to get the new updates. Okay, next we have the problem with SSH Agent Forwarding. That sounds interesting.
So they say, after hacking the matrix.org website today, the hacker opened a series of GitHub issues mentioning the flaws he had discovered. In one of these issues, he mentioned that complete compromise could have been avoided if developers were prohibited from using SSH Agent Forwarding. So what does that mean? So agent forwarding should be enabled with caution. I think this is an excerpt from the man page where SSH warned you about this feature. So the warning is SSH Agent forwarding should be enabled with cautions. Users with the ability to bypass file permissions on a remote host, for example, the agent's user domain socket, can access the local agent through the forwarded connection. An attacker cannot obtain key material from the agent. However, they can perform operations on the key that enable them to authenticate using the identities loaded into the agent. So, explain that a little easier. If your jump box is compromised and you use SSH Agent Forwarding to connect to another machine through it, then you risk also compromising the target machine. So basically what it means is if you're using SSH Agent Forwarding and someone takes over the box you're forwarding through, they can ask that box, hey, could you use your key to log me into this machine? And it will. So you only use agent forwarding if you trust root and other people with access on the machine you're forwarding through.
Yeah.
So they say instead, you should use the proxy command or proxy jump, which was added in OpenSSH 7.3. That way, SSH will forward the TCP connection to the target host via the jump box, and the actual connection will be made on your workstation. If someone on the jump box tries to man in the middle of your connection, then you'll get the warning from SSH.
Oh,
so basically, you SSH to the first box, and then when you tunnel through to the second box, it's all wrapped up and goes back to your machine rather than forwarding the agent through the middle machine, so the middle machine cannot be evil. So one example of how to do this is you can configure the host bastion with its setup, and then you do host target, and you say what its host name is, the port, and you say the proxy command is actually to connect to the bastion and then forward it through to the target and the target port. So when you SSH into bastion, you're just going to have it SSH into the other one for you. Or if you're using proxy jump, it's even easier. This is a feature added in 7.3. You can just say proxy jump the host name of another machine, and it will know every time I try to SSH to target, please automatically jump host through the bastion host.
Yeah, and the syntax is much more readable.
And you can always do this via the command line rather than the config file. But anyway, important lesson. That's why agent forwarding is disabled on all the FreeBSD cluster machines.
Yes, security.
And this is how you can do it better.
Yeah. So yeah, rewrite your scripts or your SSH configs, and then you should be a bit more safe.
Yeah. If you want to know more about how all that works, I would suggest the SSH Mastery books from Michael W. Lucas.
Yeah, he covers those, and this explains some of the do's and don'ts in SSH. Okay, speaking of SSH or OpenSSH, which we mostly use, OpenBSD upgrade guide we have here from 6.4 to 6.5, which we covered in last week's episode. And this is basically starting with upgrades are only supported from one release to the release immediately following it, so no jumping over a release here. Read through and understand this process before attempting it. For critical or physically remote machines, test it on an identical local system first. So start by performing the pre-upgrade steps. Next, you boot from the install kernel, bsd.rd, and use the bootable install media, or place the 6.5 version of bsd.rd in the root of your file system and instruct the bootloader to boot this kernel. And once this kernel is booted, choose the upgrade option and follow the prompts. Apply the configuration changes and remove the old files. And then finish up with upgrading the packages by package_add-u. And alternatively, you can use the manual upgrade process if you so desire. You may wish to check the errata page or upgrade of the stable branch to get any post-release fixes. And then before rebooting into the install kernel, there's a couple of instructions here or some things you need to be aware of. And this is all listed in this manual, which is quite comprehensive. And I guess it's not too different from previous updates. So it walks you through basically configuration and the syntax changes, files that you need to remove which aren't in the new release anymore or shouldn't be there, special packages you need to be aware of, and how to upgrade without the install kernel. Very good. So that's a straightforward guide, and you should be able to upgrade 6.4 to 6.5. Time for BSD Bits this week. We have for you a bit short but still valid the 2019 FreeBSD Community Survey.
Yes, so this is a survey for anyone who uses FreeBSD and wants to give us back some information about it. As you complete the survey, the number of questions changes depending on how you answer some stuff. So, for example, if you tell us that you don't use i386, we won't ask you a bunch of questions about i386. So the maximum number of questions you could be asked is 47. And so it should only take you 10 or 15 minutes to do it all. And we would really appreciate you submitting your feedback and letting us know how you use FreeBSD and what you think the strengths and weaknesses are there. Yep. And we'd also appreciate you sharing this to your employer, coworkers, friends, or anybody else who's interested in FreeBSD.
Yeah, because only if we know what FreeBSD is used for or where it's used or what people are doing with it, we have a better way of understanding where we should focus our efforts.
Yep.
All right, that's the survey. And next up, we have a Seagate Run, or the Seagate Run's Mach.2 demo on FreeBSD. That was interesting enough to cover in this episode. Of course.
So, Seagate's advanced technology engineers have broken new ground by demonstrating a fully functional hard drive using Seagate's new Mach.2 dual actuator technology, which is basically two separate sets of heads on the hard drive, which manages multiple sequential streams using a single SAS host bus adapter, plugged into a standard slot with no special setup. So this is basically a drop-in replacement hard drive that ideally would give you twice the IOPS.
Ooh.
So in this demonstration, their Mach.2 dual actuator technology is deployed in a pre-production Seagate Exos Nearline SAS drive. The demo took place live at this year's Open Compute Project Summit, which drew about 3,400 engineers, developers, and decision makers. The demo demonstrates the performance advantages of the Mach.2 technology in the Seagate Exos hard drive over the performance of a regular single actuator Exos drive. In this case, our workload was multiple sequential streams, for example, video streaming. So if you're pulling multiple videos off a hard drive, a regular hard drive is going to have to skip around the head a lot trying to read multiple files at once. Whereas the dual actuator drive will have twice as many heads, so each one will have to do half as much seeking. We did not have any different hardware. We just plugged in a standard drive, the Mach.2 drive into a standard SAS slot. The demonstration used 2 disk arrays, one array of 4 Mach.2 drives and one array of 4 standard drives. We load these arrays with as many of these sequential streams in parallel as they can manage and still maintain the minimum bandwidth quality of service required to play the video. We're looking at 4 megabytes per second, which is a nice high quality video stream.
Mm-hmm.
So comparing, the Mach.2 drives could run 230 videos at once at 4 megabytes per second each, whereas a regular single actuator drive could only, the array of them could only do 130 streams. So not quite, but getting pretty close to twice as many parallel operations.
Oh yeah, that's certainly
interesting. It matches pretty closely to our theoretical 2-to-1 performance advantage at the micro benchmark level. So Seagate's Mach.2 dual actuator technology doubles the performance of traditional hard drives by using 2 actuators that can independently seek, access, and transfer data to the host concurrently. So it also means that individual disks can demonstrate up to 480 megabytes per second of throughput instead of only about half that, making them faster than even the 15,000 RPM drives. In particular, to say it was designed for our customers who are running into IOPS per terabyte quality of service requirements that are no longer met by regular hard drives. The number of IOPS you can get out of a hard drive hasn't really gone up in the last 15 years. But the size of the drives have, gone up by orders of magnitude almost.
Yeah.
And so being able to double the IOPS means that that rate isn't quite as bad as it used to be.
Mm-hmm. And you see the FreeBSD logo in the video or on screen.
In the corner.
But no real mention in the article itself because it's about the hardware and not the software that they're running it on.
Mm-hmm.
Speaking of disks, we also have a resizing and growing disks on FreeBSD YouTube video that someone has started. And so, yeah, if always you always need to grow and have newer disks or bigger disks in there, you can do that on FreeBSD, and that's how the YouTube is describing it to you.
It was actually based on the handbook chapter that I wrote after someone asked me how to do this.
Yeah, see? People make videos out of that now.
Yep.
And here's some thing from the attic. Loading 4.9 on an old Tandy 4025LX 386, 16 megabyte, 1 gigabyte HD. Good old external SCSI CD. This is on Reddit.
Yep, so this is installing FreeBSD 4.9, which was quite more modern than a 386. Like FreeBSD 4.9 would be, I don't know, probably around 300 to 500 megahertz days, I think. Or no, maybe even almost gigahertz days. It was mostly pre multiple cores, but it was definitely getting into the gigahertz days.
Mm-hmm.
Like I think your average FreeBSD 4.9 box probably had 64 to 256 megabytes of memory, as opposed to this one with 16.
Yeah, well, start low.
Mm-hmm.
Here's the nostalgics. Here we go. The comments here. Yeah, cool setup. And yeah, it seems to work.
Yep. And lastly, in the BC Bits, we have a further update on that OS 108 thing we talked about the other week.
Yes. Yeah, I remember this one. So we have the forums here, and we see some images. People also told us how to pronounce mate properly. So thanks for that.
Although the people I talked to from Canonical on the weekend who work on mate for a living are like, we don't actually care. But they do
call
say
it as
mate
you like
when they talk about it. So
yeah, okay, so that's the correct pronunciation. And here's what has changed since the last release. The splash screen was added and the USB image file is now available.
Yeah. Okay, on to the feedback.
Feedback is always good to have, especially if people send it to us. That's why we are always asking you to send everything that you have questions about or want to discuss or have us talk about to feedback@bsdnow.tv so that this section doesn't die out because no one is sending us these things. The first is Casey about Oklahoma City, and James writes 2 sentences. I just watched show 289, great as always. Oh, thanks. And was excited to hear James' question. I live in Tulsa and would be happy to go support James if and when he does his talk at the OKC Linux users group. It would be great to meet another BSD user from Oklahoma.
Yeah, I think that's kind of a good idea. Is if you're out there giving your talk for the first time, it's nice to have some friendly faces in the audience, or other people will at least know what you're talking about, right?
Oh, sure.
It's good to have support.
Yeah, and some BSD folks are hiding inside Linuxes or Linux user groups, but they just want to break free from that sometimes and just know more people.
And it can be interesting to organize a week where you get a whole bunch of BSD people to travel down to a Linux user group and do a show of force of BSD.
Oh, yeah. And you never know what people find interesting in that and then maybe switch at one point. Okay, so thanks for that. So, yeah, go to Oklahoma and provide some support. Michael is next with a question on SAS backplanes with camp control ? A bit longer. Hey, Alan and Benedict, I've got a super micro storage bridge base server, 2 nodes connected to a shared SAS backplane, and I just popped in a couple SATA SSDs. Since it's a dual path SAS backplane, I grabbed a couple SAS interposer cards so that I could use them via either server. I'm not planning on doing any sort of cluster file system or similar, since from all accounts the interposers aren't super reliable or designed for that, but I wanted the flexibility to address them from whichever node was best, depending on which I ultimately decide to use them for. Unfortunately, it looks like the SSD is only registered with one of the two servers upon being plugged in. I'm fairly sure I can deregister one and have the other server pick it up, but I'm a little confused as to how. I've looked at the cam control man pages, which I think are the right place, but honestly, they're a little over my head and I don't want to accidentally mess up my server by running the wrong thing. You guys have been asking for questions, so I figured I'd float it over. Maybe you can give me a pointer. Here's a bit of output.
Yeah. So if you need to look at the actual layout and get the SES information you're talking about there, where you can see, DA11 is past 14 and is in slot 15 or whatever, sesutil is a command that Baptiste Orson and I put together based out of some example code that I think Alexander Moten had been maintaining in the tree for a long time, but wasn't actually compiled into a utility. So the hardest part with this is the fact that you're using SATA drives. With a SAS drive, they are what's called dual ported. So even though there's only one cable plugged into it, they can actually speak over basically two channels and make it easy for the drive to talk to both machines. But yes, with the interposer cards and trying to access them from both, I'm not so sure. Now, there are some cam control commands there, and if you're using the ones that are specifically targeting the backplane and telling it stuff, like register and deregister and so, those don't risk breaking anything. Worst case, power cycling the shelf and or the server will clear all of that and it'll be fine. I think if you read the cam control man page, I have one handy here,
which is quite big.
Yes, but in particular when you're looking at the persist command, which is how you do most of the multipath stuff. I've only used it the other way, where I was all SAS drives, two heads connected to one shelf, and I wanted to make sure that only one server could see the hard drive at a time, so the other server wouldn't try to mount the drives from the first server, so that only one of them could use it at a time, so that I wouldn't get corrupted data. So the persist command is sorry.
Googling a couple.
So yeah, if you do persist with the, I think if you did preempt, you might be able to kick it off the first server and take it on the second. I'm not entirely sure. Maybe somebody in the audience will know better. But it's also possible that it just doesn't work because the drive doesn't show up the second time because it's a single ported drive.
Yeah. If someone knows this and send this to us, we'll connect folks, of course, together to have the answer, and we'll also cover it in the show, of course, for other people. So yeah, this might be the best option here.
Yeah, and remember that the device numbers will be completely different on the other machine. So just because it's past 14 on the first server definitely doesn't mean past 14 on the second server will have anything to do with it. They can have completely different device names.
Yeah.
So yeah, sesutil map might be a helpful command, but yeah, cam control persist is probably the place you want to look. And for the, trying to deregister the device on this first server so the second server can see it. I'm not sure how practical that is with SATA drives. When I built this setup like that, I purposely had to pay extra for SAS SSDs to not have this problem. I don't know if it's possible to work around it or not. Hopefully, but I don't know.
Okay. Thanks anyway for your feedback and that you are enjoying the show. Last but not least is Alice, OpenBSD, FreeNAS, and OpenZFS questions.
Ooh.
Goes like this. Hello, Alan and Benedict. I have a few questions for the show. I'm an OpenBSD user, and I also have a FreeNAS server at home. First question, what is the most efficient / fastest way to get storage on FreeNAS to be used on OpenBSD? Is Samba the way to go, or maybe NFS? Does NFS offer any password certificate-based security? Is there any other protocol that I may be missing, but that would be allowing me to use the storage from FreeNAS to OpenBSD?
NFS is probably your best bet.
On Unix, yeah.
Samba can work. I don't know what the Samba clients for OpenBSD are like. NFS, I think there's a way to do Kerberos-based authentication or something, but in general, NFS kind of relies on the fact that you control access on the FreeNAS by IP address. When you set up your NFS shares, say, these IPs are allowed to access it.
Yeah.
And you trust that the username on the OpenBSD box that is passed over NFS is the same user that would exist on the FreeNAS with that name, and that you can control access with regular Unix permissions that way.
Yeah. That seems the most viable solution. Okay, so the second question is, on OpenBSD host, I have a VMM as a virtualization platform and run Linux to develop .NET Core applications. I keep hearing you guys talk about the goodness of snapshots in OpenZFS, so I was wondering if there's a way I could incorporate snapshots to back up my work. I guess I would have to expose storage from the FreeNAS to the virtual machine and then do snapshots on FreeNAS, right? Do you know any protocol that would be the best to do that?
iSCSI might be the best answer for that.
Oh, like a zvol to export?
Yeah, zvol exporter of iSCSI, because iSCSI is basically designed to export block devices over the network. I think there's an iSCSI client in OpenBSD. I'm like 80%
Initiator?
Sure.
Or in ports, somewhere.
And it's probably going to be the highest performance and the easiest way to do it.
Yeah, and then you get regular snapshots when you set that up on the zvol. Okay, third question. Is X11 forwarding the fastest possible way to run remote applications on local machines? I would like to use Visual Studio Code, which works on Linux, from VMM guest on the OpenBSD host. I tried it and it feels a bit slow. I hate the idea of having a VNC session open just for one application. Is there anything else that would allow me to run a remote application on local X server natively fast? I would use RDP. There are a couple of RDP clients, and the RDP server is, what's it called? I haven't used it in a while. Yeah, something like that.
Or you're thinking of Guacamole.
Yeah, or XRDP. Or is that the client? I'm not sure. So that sets up a RDP server, basically, and you can connect over RDP. Because RDP, as Microsofty as it might be, has a couple of good things there that saves.
So, remote desktop protocol is a bit more like X11 forwarding, where rather than sending bitmaps of the screen, like VNC is basically take chunks of the screen and send that as compressed images to the other side. RDP is a bit more like X11 forwarding, where you send draw a window that's this big by this big with the top left corner at this pixel offset, and then draw, this button widget and that drop-down list widget or whatever. I'm surprised the X11 forwarding seems slow. I wonder if there's a reason for that.
Yeah, or maybe if you have a firewall that you want to maybe give it some more.
He's running Windows, or he's running Linux in a VM on the machine. They're using X11 forwarding to connect from the host machine into the VM, so there shouldn't be a firewall in the way.
Yeah, true.
I don't know if it's the network on the guest that might be too slow.
It's not real time. Yeah, there's certainly some kind of delay. Maybe it's in VMM.
Right, but the delay of talking to a machine in a VM on your host shouldn't be much any higher than talking to a different machine across the network.
Sure.
Especially, consider X11 forwarding was meant to work at, 20 years ago internet speed.
Yeah. Maybe it's something OpenBSD specific in there because of the Xenocara thing. And
right, but I'm guessing it might actually be related to the speed of the network in the virtual machine.
Yeah, could be. Or that's where I would look. Okay, he closes with, love the show, keep up the good work, thank you, and greetings from Slovenia. Oh, wow, see, we're totally international. Last week, there was someone from Australia, Slovenia. Yeah, keep adding where you are watching us, so that's a good feedback to us. With that, we say thank you for watching this episode, and see you next week.
Yep, and don't forget to do the FreeBSD community survey.
Yeah, it's important.